Bismillahirrahmanirrahim. We start a new chapter in today's discussion, that is memory management. From here onwards, our focus of discussion will be memory, since there are more than one instance of memory in your system. Memory is of different types in our system. So every type of memory requires different management techniques that we will be discussing, both for the primary memory and for the secondary memory. So 3 different chapters are dedicated to memory management, in which this particular chapter that we are going to discuss or start our discussion on today is the primary memory. And when this chapter gets ended, we'll then start discussion on the secondary memory. Earlier to this chapter, we have been discussing on different actions or activities that a user process performs. And we have also discussed different events that have been performed or user processes. We discussed what is a process, different types of processes, what are different states a process shows during its lifetime within the system. And then we discussed how processor or CPU is managed or multiplexed among different processes. We discussed different algorithms on CPU management. Then we also discussed a problem that is generally occurred in our system due to processes, that is deadlock. And we discussed techniques how we can handle that problem. CPU is a resource. We discussed CPU scheduling in detail. Now memory is also a resource. Primary memory is generally limited memory, and so many processes are to be placed in the primary memory. By primary memory, we basically mean RAM, keep in mind. So more than one process at a time stay in RAM. That means the memory or primary memory. So again, after discussing CPU, which is a resource, how CPU can be multiplexed, that was a single instance of resource. Keep in mind, CPU generally is having a single instance. So one CPU is multiplexed among so many processes. But now is the case for memory, which is again a resource that is required by processes. But since this memory has multiple instances, so it can be shared by more than one processes at a time, while CPU cannot be shared among more than one processes at a time. One process has to use CPU at a single time, while memory can be used by more than one process at the same time. As you can see, RAM has been occupied by more than one processes at a time. So more than one process can reside in RAM at the same time. Let's proceed with the discussion agenda and see what are the points that we are going to discuss for the main memory or RAM management, how we can manage or how operating system manage RAM. This is all what we are going to discuss in this chapter. We will revisit the concepts related to memory in order to develop a background. The hierarchy of memory will be seen. Some important requirements for main memory management will be discussed next, that include relocation, protection, sharing, logical and physical organization of main memory. Then we will be discussing two types of memory partitioning: fixed and dynamic partitioning. So let's start. In order to properly understand memory management, we need to first develop our background. So first point in the outline is background. Let's see what our background is about memory. Let's revisit few concepts which we already had discussed earlier. You all know that it is mandatory for all the processes to be brought in main memory, that is RAM, in order to get executed. And in RAM, there is a ready queue in which all the ready to be executed processes reside. While we had already also discussed another queue with the name job queue, and job queue is also known as input queue, that holds set of all processes on disk. They are waiting to be brought to ready queue. You all know that a process has to go through different steps or states before completion, such as the block state, where it has to utilize different resources including many other states. So there are all the basics which we have already discussed and recapped here in order to develop your background. What is memory management? It is the task being carried out by the operating system and hardware. That means both the software and hardware have to collaborate to accommodate multiple processes in RAM. Since our system is multi-programming, so it is important that RAM should be packed with as many processes as possible. This can be done with the help of both software, which is operating system in this case, and hardware, which is memory in this case. If this task is not performed properly or not at all performed, so then only one or very few processes will stay in RAM, and among them majority will be blocked for I/O, and the processor would remain most of the time idle. And this situation can be expensive. So multi-programming or multitasking ensures more than one processes stay in RAM at a time to keep both processor and devices as much busy as possible. You all know that kernel occupies fixed size in RAM, as it is part of operating system that stays in RAM till your system is working, while rest of the RAM is divided among different user tasks. Next topic in the outline is memory hierarchy. So we will see hierarchy of memory from smallest capacity of storing data to largest capacity of storing data. Since we have different instances of memory in our system, so they need to be organized in hierarchy on the basis of space and data access time. The space here means the storage capacity. The smallest in storage capacity and fastest in access time is the register. 128 registers are working in your system and single register holds 1 or 2 bytes of data. So, register is the smallest in storage capacity. Next in hierarchy comes the cache, which resides above the registers in hierarchy. It is slightly increased in storage capacity as compared to registers, but the data access time of cache goes low. Next in the hierarchy is the primary memory, which is further higher in storage capacity as compared to cache, but much slower in access time. Disk comes next in hierarchy, having much higher storage capacity than RAM, but further slower access time. The last in the hierarchy is the different removable or long-term storage, having highest storage capacity and longest access time, as you can notice in the information given. One thing you all must keep in mind that storage capacity of all types of memory mentioned in this list is much enhanced now with latest technology. But this is just a glimpse how hierarchy differs from one another. Next point to discuss is memory management requirements. And as you can see, we have 5 different requirements for memory management, which we will discuss one by one. That include relocation, protection, sharing, logical organization, and physical organization. So let's start discussing all of these requirements one by one. Before moving ahead to memory management, some important requirements need to be clear. All these 5 requirements should be kept in mind while managing memory. First requirement is relocation. Relocation means to change the location time to time. As you all know, a process cannot remain on a fixed location in RAM all the time, as it has to move up the ready queue. A process at tail of ready queue has to reach to head of the ready queue. So no fixed location can be granted to it. Similarly, swapping also compels the process to change its location. You all know what swapping is. When temporarily a process is removed out of memory, it is known as swap out, and when it is returned back, it is known as swap in. So swapping also helps in relocation of a process. This is the reason your code needs to get translated from logical to physical address. Now, what is this logical and physical address translation? We will be discussing it in coming lectures. Next requirement is protection. Since memory is organized in non-overlapping regions, So every process in every memory slot requires protection from every other process in the neighboring slots. For protection of every process is ensured with the help of registers that work as boundary for a process. The starting address of a process is stored in base register, while the ending address of the process is stored in bound or limit register. So these two registers serve as upper and lower boundary for a process, so that no process above or below this process can violate its boundary from either above or below. Hence, protection is ensured through registers. There is some shared memory space which can be accessed by different processes, such as we discussed in process synchronization. If we have used global variables, that means they are shared among different processes. So this global variable must be stored in a space in memory that should be accessed by all the processes who require it. So processes have to access same copy of global variable from one single location, instead of copying it in their respective regions, the way local variables are stored in their respective regions. Logical organization is how a programmer develops his program and how different components in a program are organized. This is something familiar to you, as you all have designed your programs. So the way you give shape to your program is known as basically the logical organization of your code or program. A program contains instructions and data. While some functions are kept as public and private, you all must have used all these concepts: private functions, private, public functions. So logical organization deals with the organization of different components of your program, and it is totally dependent on the wish and desire of the programmer, how he designs his programs. But keep in mind, the logical organization will be totally then different than the physical organization, which we will be discussing next. Physical organization would be how your program would reside in main memory then, or you can say how main memory sees your program. Let's discuss physical organization now. The physical organization deals with how a program can be stored in memory. We are referring to main memory here. So how your program that you have designed logically can be stored in main memory, this is known as physical organization of your program. Primary memory stores data temporarily. You all know the primary memory holds your processes, your programs, your data temporarily, as it is known as a volatile memory. While the secondary storage holds your programs permanently. So how user program migrates from secondary memory to primary memory is also handled in physical organization. The secondary memory addresses are permanent addresses, while the physical memory addresses are temporary addresses, and they keep on changing as we just mentioned in relocation. So, the logical program has to be translated to physical program, or a process may move from secondary storage having permanent addresses to primary storage having temporary addresses. So how this translation and moving in and out is handled under physical organization. We will be discussing how this happens. How logical addresses are converted to physical addresses? We will be discussing this also in the coming lectures. That is all for now. We'll carry on our discussion on memory management, which is actually the management of RAM, in the next lecture. In today's discussion, we revisited some of the basic concepts that we have been discussing since the start of this subject, which is that you all know if a process needs to be executed, it has to be first brought in RAM, and then RAM is organized sequentially. Processes are stored in RAM one after another. So one after another, they are then dispatched to CPU. When a process completes its time quantum on CPU, it comes back in RAM and resides at the tail of the ready queue. Then we discussed memory hierarchy. Since at the start of the chapter we discussed that there are more than single instance of memory in your system. So we discussed different types of memory as its hierarchy. And the hierarchy is developed on the basis of size of the memory and its data access time. So the initial type of memory, or the memory that stores very little amount of data, is registers. And the more the storage location is small, the more quickly data will be accessed from it. So register has smallest capacity of data storage, but it can access data very quickly. So access time is small and data storage capacity is also small. While the largest memory is the removable memory, which stores huge amount of data, but again, since storage capacity is large, so access time is also quite large. It would require a lot of time as compared to registers to access data from removable storages. Then we discussed basic concepts related to memory management. 5 basic concepts are there. If you have to organize your memory, so 5 points need to be kept in mind. First is relocation. Your RAM is short as compared to secondary storage. So a process cannot occupy a fixed space in RAM. It has to be relocated due to different reasons. For example, due to swapping, due to suspension. So it occupies or keeps, or due to time run out, it keeps on changing its location within RAM. So a process has to be relocated. It cannot be stayed at the same location permanently. The second requirement was protection. Since more than one processes are stored in RAM, so it has to be protected from other processes so that no single process can access the boundary of another process. So it defined different registers for its protection: base register and the limit or bound registers that holds the starting and ending address of particular process. The third requirement is sharing. Some of the space in memory is shared that holds the shared data or the shared resource. For example, we discussed in parallel processing global data. Global data is the data which is shared among so many different functions. So that particular shared data should be placed at some common place in RAM, so that since no process can access the boundary of another process, but the shared data, the location where shared data is placed or stored in RAM, should be accessible to all the functions or all the processes who are to use that particular shared data. Next requirement was the logical organization. Logical organization is actually how a programmer designs his program. The size of functions, which variables are to be kept private, which are to be kept as public. So how a designer designs his program: some of the functions are small, some can be long. Whatever method is suitable for the program is what is known as logical organization. And then the last requirement is physical organization, in which actually your system looks at for your process. How a system is looking at your process is known as physical organization. That means which particular segment of your process should be loaded in RAM and rest of the part of your process should be stored at secondary storage. So whatever part is required to be executed first, only that particular part is loaded at a time in RAM, since RAM is having less capacity as compared to secondary storage. Not the complete process is stored in RAM at a time. So when there is a function call to some other function within your process, only then that particular function is loaded in RAM. Otherwise, it is at the secondary location. So these were the points that we discussed in today's discussion. We'll carry on our discussion on main memory management, that is RAM management, in the coming lecture. That is all for now. I thank you all.